As another illustration of moments of forces, note here we've got what's called a shelf angle. This little steel piece is in the shape of an L or an angle, is attached to the wall with two anchors, screws here, and what we're interested in is the effect of this force on these screws. Right now, the equivalent system that we're suggesting is here, replace that force P with an equivalent set of demand onto the screws itself. For a variety of different reasons that we won't get into here, we're going to assume that the vertical effect of this system is split evenly between B and C, the location of the two fasteners. Now, the overturning effect, right, of this force sitting out here at 5 inches away from the wall is to try to rotate this shelf angle into the wall in a counterclockwise fashion. So we're going to replace this force P with two forces equal opposite direction but set apart by 3 inches. So note here what happens with this equivalent set. So from a translation standpoint, right, we have a sum of forces in the Y has to be the same on each one. That would be in system 1, we would end up with, we just have P. In system 2, we would have 2V, so therefore, statting them up here, V would have to equal half of the total load. Right, from a rotational standpoint, then that would be sum of moments. Let's take, for instance, sum of moments about C. In system 1, that would be perpendicular distance of 5 to the line of action of that force. Let's get a sign convention here. Let's take counterclockwise positive. So that would be 5 inches times P. Over here in the other one, note, the two V's go through point C, so they got a moment arm of 0. This F has a moment arm of 0. And so you're only left with one of these F's, and it's 3 inches away. It's also going counterclockwise, so we have 3F. Therefore, F has to be equal to 5/3 of P. And then if we go back to the translational thing, just to make this really complete, if we look at the X, note there are no X forces in our model to make equivalent here, and in the second system we have F minus F equals 0, so that's exactly what it's supposed to be. So our answer here is that these two equivalent forces are going to be like so, right? Those two forces F represent what's called a force couple. We've got two parallel forces and they are of equal magnitude. And so whatever their distance is between them, that'd be the perpendicular distance, then that is equivalent to a moment M. Doesn't matter where that point is, because no matter where that point is, that moment will equal F times D, and they'll be identical from a statically equivalent or statics perspective.